Boom! Yes, folks, Hume again. How are you going? So in this video, we're going to derive certain key trigonometric ratios within the range 0 to 90 degrees. All right, remember we spoke about that particular range at the end of the previous video. And in this video, we're going to go into a little depth. Right, we're looking at the angles 30 degrees, 60 degrees, and 45 degrees. These are three angles for whom you must have an awareness of all the trigonometric ratios. You need to have them things at the tip of your fingers. Right? You need to know that cosine of 60 is so and so, sine of 60 is so and so, tan of 45 is so and so, etc., etc., etc. That gives you a very strong platform now to proceed expeditiously in certain kinds of questions where, how to put it, even if you have the option of getting a value in a calculator, if you could just write it out from a point of view of knowledge, then it makes your pathway a whole lot smoother in executing questions. So, let us start with 30 degrees. We know, we don't have to show that the sine of 30 degrees is a half. All right? So that is one of the fundamental trigonometric ratios that you will know. You know that sine 30 is a half, you just know that. Right? If you're not sure, check your calculator and see. So we start off from the essential position that the sine of 30 is a half. Of course, we know that the sine is opposite over hypotenuse. It means that if the sine of 30 is a half, then 1 over 2. We could represent that as 1 over 2. And if we have this as 1 and this as 2, then we could use Pythagoras' theorem to derive the length of the remaining side. So let me check it out. By Pythagoras' theorem, we know that 2 squared is equal to, hold on. By Pythagoras' theorem, this is the adjacent side, right? So this is the side that we're missing. So using Pythagoras' theorem, we know that 2 squared is equal to, opposite squared is how we just do it, right? O plus h is equal to 1 squared plus adjacent squared. All right? So 4 is equal to 1 plus a squared. So 4 minus 1 is equal to a squared. All right? So 3 is equal to a squared, which is to say that a squared is equal to 3. So therefore, a is equal to the square root, root 3. So we write it in third form. And again, that is one of the things that distinguishes AdMaths people from the maths people. So at AdMaths level, we could know that this side is root 3. So I'm going to put it in here now, right? Remember, this is a video, so you always have the option to rewind if you need to check something again. I strongly advise you to make full utilization of available technology. All right? I didn't have all of this available in my time. Right? You living in a time now where you have the luxury of looking through a whole video and you can rewind and I could check it out, whether it's my video or whether it's a YouTube video or whether it's a video from somebody else. The whole point of what I'm trying to say is whatever you're doing, do it properly. Right? So, having gone through this, we could then replace this adjacent here by root 3 in third form. And now we can say that now that we have all the lengths, we could then derive the ratios as follows. We can say then that the sine of 30 is a half, which is what we started off with. We could then say that the cosine of 30 is equal to adjacent over hypotenuse, root 3 over 2. And we can say that the tan of 30 is equal to 1 over root 3. Where I get root 30 from, partner? 1 over root 3. Alright? Right. So, that's 30 degrees. And of course, we're going to do the same thing across here, in the case of 60 degrees. Just as is the case with the angle 30 degrees, we have certain knowledge of certain ratios where 60 degrees is concerned. So in the same way that we know that sine 30 is a half, we know that cosine 60 is the same a half, right? So we can say then that cosine 60 is a half, which means that the adjacent is 1 and the hypotenuse is 2. So adjacent over hypotenuse, cosine 60 is a half, which means that we can use Pythagoras theorem to get the length of the opposite side. So same story, 2 squared is equal to O squared plus 1 squared. Alright, so 4 is equal to O squared plus 1. So 4 minus 1 is equal to O squared. So 3 is equal to O squared. So O squared is equal to 3. So therefore, O, which is the opposite side, is equal to root 3. Same calculation as we did across here, it's just that the sides are a little different, but I make sure and write it out so that you can see it. You can't say I just skip and I went through it, right? So we're going to replace this O for opposite with root 3, just as we did across here for 30 degrees, which then would put us in a position, all right, we're rubbing off here now, where we can see, just as we did for 30 degrees, we can say that the sine, well, in this case, we start off with the cosine. So there we go. The cosine of 60 is equal to a half. So the sine of 60 is equal to root 3 over 2. Right? At this opposite over hypotenuse, sorry. And then the tan of 60 is equal to root 3. Right? Root 3 over 1. The tan of 60 will just be root 3 over 1. Alright? And we're going to do the same thing for 45 degrees. So just as we know that the sine of 30 is a half, and we know that the cosine of 60 is a half, we also know that the tan of 45 is 1. Alright? So knowing that the tan of 45 is 1, we start off like this. Tan is opposite over adjacent, 1 over 1. It means that we can then use Pythagoras theorem to find the length of the hypotenuse. So we know then that using Pythagoras theorem, that hypotenuse squared is equal to 1 squared plus 1 squared. H squared is equal to 1 plus 1. So your H squared is equal to 2. So it means therefore that your H is equal to root 2. So we replace H by root 2. Replace H by root 2. And having done that, we can now derive the appropriate relationships for sine, cosine, and tangent of 45 degrees. So we can say, having started with tan of 45 degrees is equal to 1. We can say then that the cosine of 45, cosine 45 is equal to 1 over root 2. Watch it now. Adjacent of hypotenuse, 1 over root 2. And we can say that the sine of 45 is equal to 1 over root 2. 1 over root 2. Of course, you realize that sine 45 is equal to cosine 45. And that being said, if sine 45 is equal to cosine 45, then sine 45 over cosine 45, sine over cosine being equal to tan, then sine over cosine will be equal to 1, because anything divided by itself is equal to 1. And look, we have the same one right there. Alright? So these are some key relationships that you must have at the tip of your fingers when you're doing the pupil angles. Now, in fact, no, I'll do that in the next video. So in the next video, we're going to make the switch from degrees to radians. Right? Remember, we would have discussed radians as, I think it would have been the very first video in the series on trigonometry in this AdMaths platform here. So now we're going back to making the link between degrees and radians. Remember, one of the things that you will be called upon to do is to switch between degrees and radians in both directions. So you have to be able to do that, to make the switch. So in this case, what I did, I started using what we're familiar with, which is degrees. And having done that, we're going to make the switch to radians in the following video.